Have you ever wondered what the results of a OLS regression model mean? Let's break it down together. Dependent variable. The dependent variable is the variable that the model is trying to predict or explain. Model. The model will indicate the type of regression model that was used. Standard error. The standard error measures the accuracy of the coefficients. A lower standard error indicates a more accurate coefficient. P-value. The p-value, short for probability value, is a fundamental concept in statistical hypothesis testing. It quantifies the strength of evidence against a null hypothesis and helps determine whether the results of an experiment or analysis are statistically significant. R-squared. The R-squared is the proportion of the variance in the dependent variable that is predictable from the independent variables. A higher R-squared indicates a better fit of the model. Adjusted R-squared. The adjusted R-squared takes into account the number of predictors in the model. It only increases if the new term improves the model more than would be expected by chance. Number of observations. Number of observations. In a regression, the number of observations will represent the number of data points used in the model. DF residuals. The degrees of freedom of the residuals is the number of observations minus the number of parameters. The DF model. The DF model is the number of predictors in the model, not counting the constant. Covariance type. The covariance type is the type of covariance estimator used. For example, a non-robust estimator could be used, which means the model doesn't account for heteroscedasticity or autocorrelation. Coefficients. Coefficients represent the estimated values of the parameters in the regression equation, which describes the relationship between the independent variables, also known as predictors or features, and the dependent variable, also known as the target or outcome. T-statistic. The t-statistic, also known as the t-value, is a measure used in hypothesis testing to assess the difference between the sample mean and the population mean, or to compare the means of two groups. It is a key component of t-tests and is derived from the sample data. Confidence interval. A confidence interval is a range of values calculated from sample data that is likely to contain the true population parameter with a certain level of confidence. It provides a measure of the uncertainty or variability associated with estimating a population parameter based on a sample. The confidence interval is typically expressed as a range, along with a specified level of confidence, usually represented as a percentage. For example, a common choice for the level of confidence is 95%. A 95% confidence interval means that if we were to repeat the sampling process many times and calculate the confidence interval each time, approximately 95% of these intervals would contain the true population parameter. F-statistic. The F-statistic is a measure used in analysis of variance, ANOVA, to assess whether there are significant differences between the means of two or more groups. ANOVA is a statistical method that compares the variance between group means to the variance within groups. The F-statistic is the ratio of two variances and is used to test the null hypothesis that all group means are equal. In ANOVA, data is typically organized into several groups, and the F-statistic is calculated based on the variability of the data within each group and the variability of the data between the groups. Probability F-statistic. Prob F-statistic refers to the p-value associated with the F-statistic. The p-value is a measure of the strength of evidence against the null hypothesis. The p-value associated with the F-statistic indicates the probability of obtaining an F-statistic as extreme as the one calculated, assuming that the null hypothesis is true. In other words, it measures the likelihood of observing the observed differences between group means purely due to random chance, given that there is no real effect or difference between the groups. A small p-value, typically smaller than the chosen significance level, often denoted by alpha, commonly set at 0.05, suggests that the observed differences between group means are unlikely to have occurred by random chance alone. In this case, researchers would reject the null hypothesis, indicating that there is evidence of significant differences between at least one of the groups. On the other hand, a large p-value indicates that the observed differences between group means could have plausibly occurred by random chance. In this case, researchers would fail to reject the null hypothesis. Log likelihood. Log likelihood is a concept used in statistics and machine learning to evaluate the goodness of fit of a statistical model to a set of observed data. It is a measure of how well a given model explains the observed data, and it is often used in maximum likelihood estimation (MLE) and likelihood-based inference. AIC and BIC. AIC and BIC are both information criteria used in statistical model selection to help choose the best fitting model among a set of candidate models. They are useful tools for balancing model complexity and goodness of fit, aiming to avoid overfitting, a model that is too complex and fits the noise in the data, and underfitting, a model that is too simple and fails to capture the underlying patterns. Condition number. In linear algebra and numerical analysis, the condition number is a measure of how sensitive a mathematical problem or system of equations is to changes or perturbations in its input or coefficients. It quantifies the stability and accuracy of solving the problem using numerical methods. For a given problem or matrix, the condition number is defined as the ratio of the largest singular value to the smallest singular value. If the matrix is square, it is the ratio of the largest eigenvalue to the smallest eigenvalue. Durbin-Watson. The Durbin-Watson statistic is a measure used in statistical analysis to detect the presence of autocorrelation in the residuals of a regression model. Autocorrelation occurs when there is a correlation between the error terms, residuals, of a regression model at different time points or data points, violating the assumption of independence of residuals. The Durbin-Watson statistic takes values between 0 and 4 and is often denoted as dW. It is calculated based on the residuals of a regression model and is used primarily for time series data or data with a natural ordering. Probability of omnibus. The probability of omnibus is a statistical measure used to assess the overall significance or goodness of fit of a regression model. It evaluates whether the model, as a whole, explains the variance in the dependent variable significantly better than a constant, intercept-only, model. This is just one of several measures used to assess the overall goodness of fit of a regression model. It should be considered along with other diagnostic measures, such as R-squared, adjusted R-squared, and other significance tests for individual predictors to evaluate the model's performance. Jarque-Bara. The Jarque-Bara test is used to test if the data have the skewness and kurtosis matching a normal distribution. A large Jarque-Bara statistic and a prob, JB, close to 0 indicate that the data do not have the skewness and kurtosis of a normal distribution. For example, if the value of the JB statistic is very large, and the p-value is 0, it indicates a strong rejection of the hypothesis that the residuals are normally distributed. Skew. Skewness measures the degree and direction of asymmetry. A positive value indicates a long tail in the right of the distribution, meaning the right side has more and larger values, while a negative skew indicates a long tail in the left. A skewness close to 0 indicates symmetrical data. Kurtosis. Kurtosis is a statistical measure used to describe the distribution of observed data around the mean. It is used to identify the extreme values in one versus the other tail. It is actually the measure of outliers present in the distribution. High kurtosis in a data set is an indicator that data has heavy tails or outliers. Condition index. The condition index is a measure used to assess multicollinearity in a multiple regression model. Multicollinearity occurs when two or more predictor variables in a regression model are highly correlated, making it difficult to separate their individual effects on the dependent variable. Notes. The Notes section typically refers to a section or area where researchers or analysts can add comments, explanations, or other supplementary information related to the regression analysis and its results. It is an optional section that allows the person conducting the analysis to provide additional context, insights, or interpretations that may not be readily apparent from the numerical outputs or tables. These are important to ensure the model is valid. You are making a great step in your career. Learning how to interpret a regression is important for several reasons, especially if you work with data, statistics, or any field that involves quantitative analysis. Here are some key reasons why learning regression interpretation is valuable. 1. Understanding relationships. 2. Making informed decisions. 3. Identifying important factors. 4. Assessing model fit. 5. Validating assumptions. 6. Diagnosing problems. 7. Communication and reporting. 8. Learning and research skills. 9. Building predictive models. 10. Enhanced problem solving. Now you know.
Hello, thanks for joining us in this deep dive into OLS regression analysis and its potential benefits in data science. We hope you found it informative and useful. If you enjoyed this video and want to see more content like this, be sure to hit the like button below and leave us a comment with your thoughts or any questions you might have. Your feedback is invaluable in helping us create content that best serves you. Don't forget to subscribe to our channel to stay updated with our latest videos. Click on the notification bell so you'll be the first to know when we post new content. Also, you can become a Patreon supporter today. Until our next video, keep learning and stay curious. Thanks for watching.